Now, let's consider some Web API model anti-patterns, or things that you typically want to avoid when designing your models. Some common problems in model design, including choosing non-standard names for things like IDs, paging links, or resource names that clients don't understand. Another common occurrence that usually impacts teams who have a more data-centric view of software will be API models that are just a little too close to the database tables they're wrapping. Make sure clients of your API remain unaware of how your data might be persisted. Keep your database naming practices out of your API models. Obviously, once you expose an API and clients are consuming it, you want to avoid changing it out from under them without notice and without providing versioning support. While you should absolutely make some effort to size your models appropriately, you should also provide some mechanisms that allow clients of your API to control the size of responses. This would include things like filtering and querying, as well as the ability to drill down into more detail by using less verbose models in list responses than in individual responses. Finally, regardless of the decisions you make about how you are going to design your resources and API model representations, make sure you're able to provide some kind of documentation for your clients. Provide an interactive testing tool like Swagger with Swashbuckle, or just provide written docs or both, but in any case, make sure the docs are clear, complete, and current. Imagine you have a blog engine and you expose an API to view its posts. Here's what that might look like if you used the WordPress blog engine database schema directly as your API model. A few things to note here. ID is capitalized. JSON typically uses camel casing and would use a lowercase ID. All other fields are lowercase, not camel case. They're using underscore for separators, pretty much just with their prefixes. By the way, all fields, except for ID, have a prefix, and most of these could be omitted or made part of a camel-case field name. There is no relationship in the JSON schema to post author, and it's not described as an ID in any way, it's just there as a number. And there's no relationship in the JSON schema to comments, just their count. This may be a useful optimization, but ideally there should also be some information on how to load the comments themselves, too. Remember that going between a relational data store and a document format like JSON requires some thought. Make sure your models in the JSON or whatever format the client works with, maybe XML still, make sure that those models adhere to the standards and conventions of that wire protocol format. Here's one way the previous example could be improved. Names are now using camel case as the standard convention. Unnecessary prefixes have been removed. Links to resource URIs are in place instead of just numeric keys with no additional information. All of these improve the model compared to the obviously DB-centric one that we saw in the previous slide. That's it. Let's review what we covered in this module. First, we looked at some basics of Web API models. Remember, they should be data transfer objects and should only include the data needed for the operation in question. Next, we reviewed Postal's law, the robustness principle, and we also took a look at another related law, Hiram's law. Keep your APIs usable for the long haul by following these principles. We considered how to structure the data that our APIs return. We learned about summary versus detail representations, and options for paging and navigating large resource collections. We wrapped up by looking at some characteristics of good Web API models, as well as a few anti-patterns that you'll want to be careful to avoid. I hope you enjoyed this module and learned a few things along the way. Up next, we'll look at some best practices to keep in mind when implementing Web APIs using ASP.NET Core. Stay tuned. Welcome, I'm Steve Smith, and in this module, we're going to learn some best practices to keep in mind when implementing Web APIs with ASP.NET Core. As ASP.NET Core has matured, Microsoft and the community have introduced a number of options and improvements to how you can build these APIs. In this module, we're going to focus on some implementation-specific best practices, starting with ASP.NET Core MVC, which has a ton of great features many developers don't even know about or take advantage of. Then, we'll briefly look at using Mediator to help reduce controller bloat and coupling. Then, we'll take a look at how to move from controllers to endpoints, and then we'll shift gears to look at an alternative to MVC, minimal APIs, and some best practices for organizing and utilizing this different approach to building APIs. Finally, we'll wrap up by showing how to use background services with your web APIs, which can be a useful way to offload work that doesn't need to happen as part of an individual request.